Okay, guys, here we go. I think we're on now, finally. Oh man, that was a mess. Hey guys, what's up? Welcome back to the live stream for the Scalar Learning channel. My name is Huzefa, and we are having some technical difficulties, guys. So now we are finally back on track. Hold on, give me 1 second. Sorry about that. We had some connectivity issues. Hopefully, people are able to find the stream and figure out what's going down now here. Okay, so all right, give me 1 second, guys. Okay, so the one that is happening, we're gonna post it here. Let me post the link. No, not okay. Give me 1 second. We're fixing it. We're fixing it here. Okay, got it. I'm on here now. We're going to copy this, and we are going to here. I'm just letting everybody know in the other one here. Check it out. Check it out. Boom. There is the new link. Click there and you will be on the live stream. Okay, there we go. Oh man, I am so sorry, everybody. All right, I see some people popping over now. Okay, what's up, everybody? Welcome to this live stream. I'm so sorry. We're more than 15 minutes late, and let me tell you what has been going on. There was some technical issue. I don't know what it was exactly, but something with my streaming software. And I think that when I had tried to connect another streaming software to it, the old one was no longer working. I didn't know that was going to happen, but I was trying to get it to work and trying to get it to connect, and it just wasn't working. Anyways, so I switched back to the new streaming software. Not that you guys really care, but just let you know. And now, finally, after a couple tries, it seems to be working. So we are back on track. And hopefully everybody will click over and join us shortly. But no, we are not postponing. No, we are not delaying. We are doing this today. We're working on the presentation for quite a while, and we got it ready to go. So we are here. And thank you guys so much for joining. It's amazing to have you guys. If you guys can hear me and are on the stream, please let's start by, if you give me guys a like, that I would really appreciate it. I know we haven't really started yet, but if you anticipate that you will like what you see, which I'm sure you will, a lot of thought has gone into this content, make sure to click that like button. I really appreciate it. It really helps the channel. And if you haven't subscribed yet and you do want to join along in this journey, make sure to click that subscribe button. Now, the other thing that I did want to share with those of you guys who are joining the stream, if you have not joined our school community yet, that's where we are kind of posting all the announcements, posting the homework assignments, etc. I want to post it in the chat right here. So here is our website. Now, it's also in the description as well. You can find this link and click there. Everything is totally free. I highly encourage you to join it so you can stay along and see the calendar and see the updates and all that good stuff, which is going to be really, really valuable. The other thing is you guys can potentially collaborate with each other, join study groups, set up study groups, work together, talk to each other about how the homework assignments are going. I think that's going to be tremendously valuable for everybody along the way. Okay. So that is it. Now, today I'm going to close one of these other windows here. Okay. Now, today, what we are working on is SAT math critical concepts. And in particular, we are on presentation 1 of part 4. Now, we're going kind of in order. So let me do my quick little screen share here. All right. So we're going to share. Oops. Where is it? There it is. Okay. All right, so you guys can see everything hopefully clearly and nicely. We're going to start with critical concepts part 1 of 4. And in particular, we are looking at, oops, let's see here. This slideshow is not working. Come on, guys. No more technical difficulties. There we go. All right, we are looking at algebra. Okay, that's what we were talking about today. Now, if you guys remember from the everything you need to know about the digital SAT presentation, algebra is the first of 4 broad categories for the critical concepts. So we're going to talk about everything you need to know about algebra, and we're going to dive right in. And I think this is going to be a lot of fun and very valuable for all you guys checking this out. Now, another thing I want to say before we jump into the mix, why don't you guys let me know, for those of you guys who are online right now, let me know where in the world you're at. I know Dan asked this on Thursday, and that was super cool to see exactly where everybody is kind of logging in from around the world. So if you guys could just let me know what location on the planet you guys are at, that'd be super cool. You might also want to put in there what your ambitions are. Why are you taking the SAT? Why are you prepping for it? Why do you care about your score? I'd love to hear your thoughts. So first we have Eric coming in here. Eric saying that they're from Texas, New Jersey. Very cool. Istanbul, Nesselson. I know a little bit of Turkish. I spent a lot of time out there. I'm trying to remember. Günaydın is good morning. I remember a couple of other words too. New Jersey as well. New York for Nafisa. We got Ethiopia. How cool is that? And I know Abinet, if I'm pronouncing your name correctly, you've been very active in the chat and on the school website. So that's super cool. Welcome, welcome. And if we got any other cool locations, please go ahead and share them. Now, coming back to this, algebra. Okay, this is the core of this entire test. Obviously, what we're going to go over here, there's more than just what's gone over today. There's going to be additional algebraic concepts and so on and so forth that we're going to cover, but those are going to be in later critical concept videos that are going to be more targeted to the more advanced questions. Okay, we also got Matthias Hanna from Sweden. I've been to Sweden many times as well. I can't remember the name for thank you. I want to say it's Tak, but anyways. All right, so welcome. All right, without further ado, let's get into the mix. Here we go. Oh, I know what's going on. That's why it wasn't clicking before here. I got to turn this on. So the drawing on page. Here we go. Let's see if I can close this. I just uploaded this little drawing tool, but see, it's giving me it's glitching. Hold on, give me 1 second. All right, hold on, guys. I'm gonna just stop the screen share for 1 second. Let me just get rid of this little thing here so we can start stepping through. Oh, there we go. There we go. I got it. Okay. Ba-da-da-da-da. Here we go. All right. Now, talking about algebra. So what are the subcategories under the algebra umbrella? Okay. So we're going to talk about solving linear equations and inequalities. This is straight from Khan Academy. So if you want to deep dive into problems particular or specific to these subcategories, you can go on Khan Academy in their math section and check these out. But we got 1, solving linear equations and inequalities. 2, linear equation word problems. We're going to talk about that section as well as critical tips and important things to knock those out of the park. 3, linear relationship word problems, graphs of linear equations and functions, solving systems of linear equations, systems of linear equations word problems, linear inequality word problems, and last but not least, graphs of linear systems and inequalities. So that's going to be graphing inequalities as well as graphing systems of inequalities or handling those types of problems. All right. Make sure to post any questions you guys might have in the chat. I'll be checking that periodically. Actually, I'll be kind of keeping my eye on it throughout. So make sure to post something if you have a question. And without further ado, let's keep going. Okay. So first of all, solving linear equations and inequalities. So we're going to start with the basics, right? We're talking about solving linear equations. If you guys know the typical algebraic concepts, and most of you guys might know this, but it all comes down to variable isolation. And to do so, we must use inverse operations. So what am I talking about? Like, just for example, we have these various operations, right? We have addition, we have multiplication, we have square roots, we have sine, okay? Just to name a few. What are the inverses? They're the opposites, okay? So what's opposite of addition? That is subtraction. Opposite of multiplication is division. Opposite of square rooting is squaring. Opposite of sine is inverse sine. Opposite of cosine is inverse cosine. So knowing these inverse operations is very important in terms of how to solve these problems. And I'm going to show you in real time how we're going to actually use these inverse operations to do a little bit of variable isolation. So let's say we have this equation right here, okay? And we are going to draw on the page to make sure this is going to work. Oh, hold on. Boom. There we go. All right. Let's make this a little thicker here. Yeah, I think like that. That's good. Okay. So we've got this situation here. Wait, let me just clear that. Boom, boom. Okay. So we got this situation. Now we're going to isolate step by step. Now, when I say farthest first, I think that's a really cool thing to remember in general because, sorry, the brush width is going bonkers here. Okay. And I think that's a really good thing to remember in general when trying to figure out how to isolate, right? Because what we have is we have a 2, we have a 3, we have a 19, and we have a 21. Okay. So we have all these different things. Sorry, let me just move this stuff. We have all these different, oh, the erase function is not working here. All right. So we have all, here, let me just clear it again. So we have all these different things that we are trying to remove, and we want to get rid of the things farthest away distance-wise first. What's up, Ranbir? So I'm going to first focus on this 19. Now, when I look at the 19, to get rid of it, it's being added to that variable, right? Plus, or the other way to think about it is a positive 19. To get rid of it, we want to do the opposite of addition, which is subtraction. So we're going to minus 19. What's up, Ishnika from India, welcome, welcome. So we're going to subtract 19 from both sides. That also makes sense because 19 and negative 19 are going to cancel out to 0. Then we have 21 minus 19, which is 2 on the other side. All right. Now we have 2 times the square root of x divided by 3. What's farthest away in terms of order of operations? The 2 is right there multiplying, but we also have a square root even more on the inside. But then the last thing that's happening to this is being square rooted, multiplying by 2, and then it's being divided by 3. So we need to do the opposite of dividing by 3. What's the opposite of dividing by 3? Multiplying by 3. So we're going to multiply both sides of this equation by 3. These are going to cancel out, and that's what we want. And then we're ending up with 2 square root x is equal to 2 times 3, which is 6. All right, now we only have a 2 and a square root. The next thing that's farther away between the radical and the 2 is the 2. The 2 is multiplying. Opposite of multiplying is dividing. So we're going to divide both sides by 2, and we get square root of x is equal to 6 divided by 2, which is 3. Last but not least, we got to undo that square root. We got to do the inverse of taking the square root, which is squaring, as we saw on the previous slide. X square root of x squared is x, 3 squared is 9, and that's how you solve it. Now, with a question like this, if you are solving a linear equation, you can plug it back in and check to see if that's correct, right? So what is the square root of 9? 3. 3 times 2 is 6. Divided by 3 is 2. Plus 19 is 21. Boom, done. So it works. Okay. And by the way, Yash is asking in the last 2 weeks after you get through critical concepts, can you go through really difficult problems? Yeah, that's 100% what we're actually going to do. That's on the schedule. So that's fantastic. Okay. So now we are going to move on. Let's delete all this stuff. We're going to move on to slide 2. Here we go. All right. So now we have another example. Now we have an inequality, right? Solving linear equations and inequalities. So in this one, whoops, not that one. Hold on, sorry. Now we are going to solve this equation. We're going to do the same thing. Again, it's variable isolation. Isolate, right? So we have a plus 16 and a multiplication of 4. The first thing we're going to get rid of is that 16. Minusing 16 on both sides is going to give me 32, and 4x still stays here. Now, the inequality is just going to stay there, just like an equal sign. So don't worry about that yet. Then we're going to divide both sides by 4, divide both sides by 4, and we're left with x is less than 8. And there's my solution. So what does that mean if x is less than 8? It means that all values less than 8 are going to be viable solutions to this inequality. So what are those possibilities? 7, 6, negative 20, negative 100. All of those are going to work. And we can see that when we plug them back into x, right? 4 times, let's say negative 100, for example. 4 times negative 100 is negative 400, plus negative 16 is negative 384. Negative 384 is certainly less than 32. So there you know it's a viable solution. Okay. 4 is, okay. So, oh wait, did I just make a mistake there? 32 divided by 4 is 8. Wait. Oh, yeah. It is. Oh, I totally made a mistake. Good catch. Sorry. I don't know what I'm doing here. So Yash just made a catch there. It's 16. My bad, not 32. So 16 divided by 4 is 4. So anything less than 4. So 7 and 6 are actually not viable options. We would have figured that out if we checked them. 4 times 7 is 28 plus 16 is 44. That's not less than 32. But anything less than 4, like 3, like 2, those would work. Now you might say, well, what about 4, right? X is less than 4. 4 would actually not work. It has to be anything less than 4. And you can see that right here. If I plug in 4 times 4 is 16 plus 16 is 32. Is 32 less than 32? No, it's equal to 32, but it's not less than 32. Therefore, it's not a viable solution. Yash, thank you for that correction. Great catch. Sorry about that, guys. All right. Well done, everybody. And let's move on. Okay. So now we are going to go to the next slide. All right. Another thing to remember. Now, this was in the formulas video from last week, but when you divide or multiply both sides by a negative, you must flip the inequality symbol. So what are we talking about here? Let's do it. Let's solve another inequality problem. Okay. So solving this one, we're again going to isolate. We're going to minus 17, boom. And we got negative 3x is greater than negative 7 minus 17 is negative 24. Then we're going to divide both sides by negative 3. X is, and then, well, let's write it out. Negative 3. Negative 24 divided by negative 3 is positive 8. But we divided by negative. So what do we do with the inequality? We flip it. So it's no longer greater than, it's x is less than 8. Okay. And we can make sure that that works by plugging in some viable options, right? X is less than 8. So an option could be 7, 6, 5. All of these are viable options. Let's just try 7, for example. Negative 3 times 7 is negative 21. plus 17 is -4. -4 is indeed greater than -7. If you're not sure why that is, think about a number line, right? If we have -4 here, -7 is over here. Values that are to the left on the number line, those are the smaller values. So it makes sense. -4 is indeed greater than -7. So it does work. -7 alternatively is less than -4. So I hope that makes sense. Okay. So that is a very, very important rule to remember on the SAT. All right, let's keep it going. Now we're into linear equation word problems. All right. So when we're talking about linear equation word problems, there's some things that we want to keep in mind with respect to linear equations. What is slope? What is the y-intercept represent? And we're going to talk more in detail about this in a later section, but in terms of what is slope-intercept form and what do these values mean. But first, let's talk about critical values in general, okay? Slope of right, this is one of the critical pieces of a linear equation, the slope. And when we have slope, we're talking about the rate of change. It's the something per something. And I'm going to put this slope intercept form up here in a second so you can see what I'm talking about. Their y-intercept is your initial value, your starting value. So if, for example, you're saying, hey, I've got $100 in the bank and then I'm making $10 a week, your y-intercept would be that starting point. You're starting with $100 in the bank, and there you go. Last but not least, we have our x-intercept. So for certain problems, they might be like, all right, well, at what point is the bank account going to go to 0, right? The function value goes to 0. That's your x-intercept, the point of 0. Now, if we take an example here, right, this is our slope-intercept form, which I said we're going to talk about more in detail later on in the presentation. We've got M as your slope, and M represents your rate of change. Your B, colored in blue, is your y-intercept. And again, that's your starting point or your initial value. So now let's take this example right here. So I want you guys to read this question on your own. I'm going to give you about 1 minute. Just think it through. I'd love to see your answers in the chat. So go ahead and think about it. Pop your answers in the chat, and then we're going to talk about it. Go for it. All right, we got some answers coming in. Give you guys another 20 seconds or so. Okay. All right, let's talk about it. And Leo, I see your question about a 1550. We're going to talk about, I'm going to answer your question in 1 second. Let me just focus here because we got a lot of people putting in question or answers to this question. So I see a lot of D's and I see 1A. Now, let's talk about how to solve this. So for training program 1 rides his bike at an average of 5.7 minutes per mile. Okay. Which function models the number of minutes it will take for Juan to ride X miles at this rate? Minutes per mile. What does that sound like? A starting point or a rate? It's a rate, right? Something per something, rate of change. So that 5.7, okay, that's going to be our M value, right? And so that should be multiplying our variable. It says 5.7 minutes per mile. So what are we multiplying by? The number of miles, which is X, okay? And hence we get this option, option D. Option D is correct for everybody who said option D. Now option A, which I think Hatice selected, which was also not a bad choice, right? It's X divided by 5.7. But the thing is, think about it like this. Another way to think about this equation is this equation. I think you might have been thinking that because you're thinking of distance equals rate times time. I'm guessing. Is that potentially why? But they flipped it. They didn't say miles per minute. They said minutes per mile. So it's kind of like a flip version of distance equals rate times time. Maybe I bet you that's what happened here. But anyways, so then since it's minutes per mile, we have minutes on the left-hand side and then that distance or the miles value on the right-hand side. The other way to think about this is it kind of like makes sense, right? If we're trying to get the total number of minutes, if you're doing 5.7 minutes per mile, two miles would be 11.4. 3 miles would be what is that? 3 miles would be 17.1, right? So which one of these, when you plug in 2, do you get 11.4? Right here. 3, you get that 17.1. So that's another way to verify once you know, hey, I know what the answer should be if I have 3 for x. Okay. Now we have another word problem. Here's another example. Oh yeah, let me answer your question, Leo. So you know, I get these questions occasionally. I want to get a score of a 1550. Now, I can't answer that in a vacuum because I need to know what's your baseline score. Why are you getting questions wrong right now? Are there major conceptual gaps? Are they silly mistakes? So all of that will be part of the rationale as to, you know, what's that time frame look like. Now, if your baseline score right out the bat is like a 1450, something super high, or a 1490 or something like that, yeah, it might not take too long. You know, you might need only a couple months, a couple months preparation and just ready to go. But if your baseline is lower, it may take a lot more time, you know. And look, a 1550 is a very, very, very high score. It's going to be super difficult. Okay, so we're gonna roll with it. You're gonna try your best, but again, I would say the higher your baseline is going to increase the likelihood that you're going to reach it. But it's not definitive because there's a lot of other factors in the mix. Um, but I would generally say look at that, and then you can start to plan out. And you have to keep tracking your progress, see how quickly you're kind of getting the information. All right, I see some. Oh, you've never done. Okay, so the first thing you need to do, Leo, is take a diagnostic. I see some answers already coming in for this. It says Hannah deposited a fixed amount into her bank account each month. The function blank f of t equals 100 plus 25t is the amount. Excuse me, in dollars. What is the best interpretation of 25? Okay. So again, we're trying to interpret it 25, and let's let you guys enter your answers. I see a couple A's coming in already. I'll give you guys another 30 seconds. All right. So now let's break it down. Let's talk about how to interpret this. So in this one, they're actually giving us a function equation. But notice what they did. The variable's on the right-hand side. This constant value is on the left-hand side. But it doesn't change anything. The order in which you place these doesn't make one different, right? The number next to the variable is always going to be your slope. So now as we look at this, that 25, okay, that's what they're asking us to interpret. The 25 is next to the t, and the 100 is our constant. That's our y-intercept. So when we're looking for the right answer, we should see 25 being defined as a rate, okay? And where we see that is in option A. With each monthly deposit, it's changing or increasing by $25. And that makes sense. T is 1, we're at 125. T is 2, we're at 150. So every time it shows the amount that is changing from month to month. Now, if this were asking about the y-intercept, the starting value, this would be the wording we want. Before Hannah made any monthly deposits, the amount in her bank was blah, blah, blah. But it would not say 25, right? And they couldn't put 20. They couldn't put the real answer because then you have two right answers, kind of. But I'd say before the amount in her bank account was $100. That's the y-intercept. That's the starting value. So that's what would be the answer if they were asking for how would you interpret 100 in this situation? Okay. All right. Now we have another potential problem. I want you guys to take a look, take your time, think it through, and we will answer. Go for it. Remember, you guys can use a calculator if you need to here. All right, we got some answers coming in. Okay, it looks like so far what we've gotten is just a bunch of C's. So let's talk about it. Now let's talk about how to break this down. So it gives this function 36x plus 1,000, where x is the monthly payment. When we're reading a problem like this, we first want to say, all right, well, x is our monthly payment, right? And then they're asking for the and then they're telling us the monthly payment is $400. And with this information, they're asking what is the total cost? And how is the total cost represented? It's f of x. So right here in this word problem, they're telling us what we need to solve for. So now let me show you, how do we approach this? Well, they're telling us we need to find f of x in green when my x value, which is in blue, right over here, is 400. So this type of linear equation word problem is a straight plug and chug. And then once you have this, use your calculator. These two multiplied against each other are 14,400 plus 1,000 gives us C for the win. Everybody got it right. What legends? Good job. All right, let's move it along. All right, now we're into linear relationship word problems. Okay. And linear relationship word problems, linear equation word problems, right? Like, what is really the substantive difference in these two terms, the way they're labeled? I don't really know, but these are the ones that I would consider to be, I guess, linear relationship word problems. So, one thing that I want to point out before we dive into these, the number in front of each variable, that's your rate per variable. Okay. When we have two items, two goods, two whatever. So, I want to dive in a little bit deeper via a practice problem. So, let's check this out. We've got, and yes, IO says there's surface area on the SAT. Yes, there is. A teacher is creating an assignment worth 70 points. The assignment will consist of questions worth 1 point and questions worth 3 points. Which equation represents the situation where X represents the number of 1 point questions and Y represents the number of 3 point questions? So go ahead. I'll give you 45 seconds. Think about it. Post an answer if you'd like, and then we'll take it. All right, we got a bunch of D's coming in, and now let's figure it out. Okay, so we're reading something like this. Again, what are we looking for? We're seeing that total of 70 points. Okay, so that's something right off the bat to identify, and they all equal 70. So that doesn't help us limit anything. Then we see that X represents the number of 1 point questions. And we also see, oh, wait, let's back it up for 1 second. So that X represents the number of 1 point questions. Now, if we're trying to get the total amount of points, right? Because that's what 70 is, the total amount of points. The total amount of points for getting X number of questions right. Well, let's say I got 5 questions right. Each one is 1 point. It'd be 5 times 1. Let's say I got 10 of those questions right. Times 1 would be 10. Now I get X number of those questions right. So it's X times 1, hence the 1X or just the X, right? Next, we have 3 point questions, which are represented by Y. So to get the total number of points for all of those 3 point questions would be Y times 3. And that's how we arrive at our answer. X plus 3Y equals 70. That's how you do it. Okay. Now we got another example here. Go ahead and read that and give it a shot. Again, the number in front of each variable is the rate per variable. Take it away. Okay, we got some A's coming in. Very nice. Oh, I just realized something too, guys. Hold on. Give me 1 second. I need to post this video properly. 1 second here. Yeah, we got an issue. Okay, give me 1 second. All right, hold on. I am going to just post this in the school website in case people are trying to click on this link in school and go into the wrong spot. Give me 1 second, guys. All right, we're going to update the link here. Almost done. Keep letting those answers come in. 1 second. Boom. All right. I updated it on the calendar. And let me update it on the community too. 1 second. Here, I'm just going to post the live link up here right now. Make sure people know. New link here. All right, 1 second, guys. Boop, ba doo, boop, boo. I don't think it's going to let me do that. Okay. All right. Hopefully, I posted it, and enough people that are on the site trying to figure out where the stream is, they're going to figure that out. Okay. Anyways, we got a lot of A's. All right, let's see if that's correct. Now, again, we're going to break it down the same way. We see our total right here is 14, and that's only an option A and B. Now, let's identify our variables, right? We've got W represents walks, right, for the number of hours. And we've got walking at a speed of 3 miles per hour. That's a rate, okay? So to get the total number of miles, which is equal to 14, we do rate times time, okay? Because that's the rate, it's in our typical rate format, right? Miles per hour. So we'd want our correct answer to have a 3 times W. Okay, what about this runs for R hours, right? When we have a speed of 5 miles per hour for running, we should see a 5R in the correct answer, meaning A is indeed correct. Well done, everybody. Good job. Okay, moving on to topic number 4, graphs of linear equations and functions. Now, when we look at these different linear equations, right, we have y equals 2x. What do we notice here? We got a slope of 2. We got a y-intercept of 0. And just so you can see, one of the solution sets is 1, 2. That makes sense. You plug in 1, you get 2 for y. Plug in 2, you get 4. All of those are viable points on this graph. Here's another example, y equals x plus 3. Notice it crosses the y-axis at 3 as our y-intercept. And here's just one example of a point, -5, -2. Plug in -5 for x, you do indeed get -2 for y. And here's another example, y plus 3 equals -3/4 x minus 4. Now, this happens to be in point slope format, which we're going to discuss later. And that point is 4, -3. Essentially, the x value of the coordinate is 4, meaning the opposite of what you have in here of this -4. And the y value is the opposite of this 3, which is -3. And our slope is -3/4, which is represented right here. And you can see it goes down by 3/4 from every point to every point. Okay, so that's your general idea of what these graphs look like. Now, we're talking about critical values again from the graph perspective. We talked about it from a word problem perspective. So again, the slope of this function is rise over run. So in this example, right, and it also represents a rate of change still. In this example, the slope would actually be 1. But if we look at these 2 points, how do I get to that conclusion? I'm going up by 5, over by 5. So rise of +5, a run of +5, 5 over 5 is 1, boom, done. We're talking about a y-intercept. That's where it crosses the y-axis. And right here, our y-intercept in this case would be 0, 3. And we have the x-intercept. That's where it crosses the x-axis right down here. And in this case, it would be -3, 0. Okay. All right. Let's keep it rolling. Now we have slope-intercept form in particular. So this is one of the forms that you need to get familiar with for these linear equations. So check this out. Y equals mx plus b. So I mentioned I would circle back to this eventually. So y equals mx plus b in this format, it makes it very nice to graph. And what it tells us is whatever constant is multiplying the x is the slope. Whatever constant out here is our y-intercept, okay? And again, the slope is rise over run. So how does this all fit together when we look at it on a graph? So check this graph out. And we've got a linear equation here. So if we look at these 2 points, that's rise over run. That would give us our slope value. What would it be here? Let's see. Oh, I kind of did like random values. I think in the next slide, I do an actual example. And again, the y-intercept is where it crosses the y-axis. So that's our b value. So now we remember this format of y equals mx plus b. And now we have an example, 2x plus 3. So check it out. That 3 should be our y-intercept, and the 2 should be our slope. So if you notice, you go from any point to a second point, right? Or starting from any point, we go up 2 over 1 to get to another point on the line. Up 2 over 1, up 2 over 1. This can be achieved from any point on the line. And that y-intercept, as I mentioned, is 0, 3, which we could tell straight up from the equation is right there. So these are two really important values that you can get from this nice slope-intercept form. Okay, another thing to note is point-slope form. This is less important than slope-intercept form, but I argue it's still pretty important. If we have point-slope form, okay, which is this, y minus y1 equals m times x minus x1. And again, m is still your slope in this case. M is going to be slope, right? And for our point, we've got x1, y1, which is just any point. So the beauty of point slope is we could create multiple versions of the same equation of the same line using different points that would exist on that line. So right here, we'll give you an example in this next slide, right? We've got y minus 3 equals 2/5 times x minus 2. Now, for this one, okay, what's the slope is, of course, 2/5. It's that red value. And what's the point that it is showing in the equation here? It's +2, +3, right? The opposites of those two values. So now if we were to look at this graph, right, you see that we got the point 2, 3 here. And we can see that indeed we do have a slope of 2/5, right? Going up 2 over 5. You know, from this point up 2 over 5, we land on the line again. So again, that is point slope. Okay, next we've got standard form of a linear equation. So what's standard form? This is ax plus by equals c. You will see a lot of equations in this format, and you'll see it on word problems as well. And for this equation, there are a couple of restrictions to be officially considered standard form. That is that a, b, and c must all be integers, number one, and the first one in front of x, a, it must be positive. So just as an example, here's an equation in slope-intercept form, y equals -2/3 x plus 7. And this equivalently in standard form is 2x plus 3y equals 21. So just to show you how we get from slope-intercept to standard, I'm going to quickly walk you through that process. So let's say we're in this process, or we're at this point. So how would I convert it? Well, I know I want to get x and y on the left-hand side. So I'm going to add 2/3 x to the left side. 2/3 x plus y equals 7. Then I know that I can't have any fractions in here, right? I'm good with the positives and negatives because everything's positive at this point. But how do I get rid of this fraction? You might be like, well, I multiply by 3 over 2, the reciprocal. But then that's going to create fractions elsewhere. So instead, just worry about that denominator, okay? So worry about that 3. So I'm going to multiply everything by 3. 3 times 2/3 is 2. 3 times y is 3y. And then 3 times 7 is 21. Whoops, glitching, sorry. But anyways, that's how we get to this point here, okay? Now, if we were to graph this, again, the graph, we could use slope-intercept form to graph it, right? We have our line here, which has a point, what is that? Oops, that's the wrong point. That's supposed to be 0, 7. Sorry, guys. That's supposed to say 0, 7. Hold on. Let me see if I can cross that out. Little glitch. Let's move that. So this is our y-intercept of 0, 7. And then we have our slope of -2/3, meaning to go from one point to another, we go down to negative and to the right by 3. Why is that 3 positive if it's a negative slope? Because both can't be negative. You can't go down to and the left 3, right? -3. Then that'd be negative and a negative. That would be like a positive slope. So again, one has to be positive, the other has to be negative for a negative slope. Or I could say up to the left 3. That would also keep us lined up on this line. All right. Abinette asked the question, why must A be positive? Great question. And I don't have a good answer for you other than that is the standard convention. So for whatever reason, we've decided that standard form that X must be positive. So, I mean, look, we could also, I can multiply everything by a negative and make it -2x minus 3y equals -21. This is still the right equation. It just doesn't technically qualify as standard form. So once you get it in this format, just make sure the x is negative by multiplying by -1, and you're good to go. All right. Let me clear everything again, and let's move on. Now we're into category 5, solving systems of linear equations. All right. So there's going to be a couple different ways that we're going to solve systems of linear equations. And obviously, for those of you guys now that know that Desmos is available, that's a great option, is to graph the equations and find the intersection point. We're going to get to that in a little bit. But first, let's take this example. So we have y equals 2x plus 1, y equals negative 2/3 x minus 7. So if you do want to use substitution, let me show you the process here. So right now I got y isolated. I actually have y isolated in both equations, but let's take this, right? This is equal to y. And we're trying to find the intersection point. So this could also be equal to y in the second equation. So now I'm going to substitute 2x plus y in for y, 2x plus 1 in for y. And now I can solve for x, right? Whoops. Sorry, this thing keeps glitching. Hold on. -7. All right. So now let's combine like terms. First, I don't want to deal with the fraction. I'm going to multiply everything by 3. So we got 6x plus 3 equals negative 2x minus 21. Then we're going to add 2x to the other side. 8x plus 3 equals negative 21. Then we're going to minus 3 from both sides. 8x equals negative 24. Divide by 8. X equals negative 3. So we know the x value of the solution set is negative 3. What's the y value? Well, to figure that out, we got to plug it back into these equations. You can plug it into either. I'll plug it into the top. Negative 3 times 2 is negative 6 plus 1 is negative 5. Now, just to make sure I didn't make any mistakes, I'm going to plug it into the bottom one as well. Negative 3 times negative 2/3 is positive 2 minus 7 is also negative 5. Double verification. That's how you do it. Done. Okay. There's another way that we can solve systems of linear equations algebraically, and that's through something called elimination. So let me show you how elimination would work in this example. Okay, so elimination, we're not trying to substitute, we're trying to eliminate one of the variables. So I take these ones, and first, like, look, I want to make sure what the variables, these are kind of lined up with the y's on top of each other, the x's on top of each other, etc. And I want to make sure that one of them has a coefficient match. Okay, and in this case, both of the y's have a coefficient of 1. So that's pretty cool. But now I want to add these together and have the y's cancel out. Well, y plus y is 2y. But I could multiply the bottom equation by -1. That becomes negative. That becomes positive. That becomes positive. Now I add these together. Watch what happens. Y plus negative y is 0. 2x or 2 minus 2/3 is 1 1/3, or we can say positive 4/3. And then 1 plus 7 is 8. Now I'm going to isolate by subtracting 8 from both sides equals 4/3 x. Now I'm going to isolate by multiplying by the reciprocal, which is 4/3. I mean, sorry, 3/4. Excuse me. Oops. 3/4. And why is that great as an inverse operation for multiplying by 4/3? Because that equals 1. It cancels out. It's beautiful. Same as dividing by 4/3, right? And then x equals 3/4 of -8, which is -6. So now we have our x value. What's our y value? Plug it into either, but I'm going to plug it into both to make sure. -6 times 2 is -12 plus 1 is -11. What about over here? -6 times -2/3 is +4. That was originally. Oh, wait. 4. Wait, did I make a mistake here? Hold on. 2 minus 2/3, 8, -8, -6. Hold on. Did I make it? Oh, did I make a mistake? Should it be 8/3? Hold on. Ba-da-da-da-da. 2 is 6/3. It should be 4/3. 1 second. -6, -12, -11, -6. No, I did it right. I did it right. It's just because, yeah, I can tell you why. It's because this was originally a minus, and this was originally a minus. So -2/3 times, no, there. Oh, yeah. Yeah, wait, I think I made a mistake. Hold on. 1 second. So we have here, let me reset all this. Sorry. Let's redo it. Okay. So back to this. Let's hope I don't make a mistake this time. So again, negate, negate, negate. Oops. And then we add them together. 0 equals 2, which is the same as 6/3 minus 2. Oh, that's a plus. That's what you're saying, 8/3. Yeah, I minused it for some reason. Good catch. So 6/3 plus 2/3 is 8/3, and then x, and then 1 plus 7 is 8. Then we're going to minus 8. We get -8 equals 8/3 x. And then last but not least, multiply by 3/8. Thank you for that correction. That's Abinet, right? Thank you. And Yash also said it too. Sorry, Yash. You were also on it. Good catch, guys. All right, boom, boom. And then we get -3. So x equals -3. And we've got -3, comma, plug it in. -3 times 2 is -6 plus 1 is -5. Double check it down here. -3 times -2/3 is +2. -7 is also -5. Boom, done. All right. But there we go. That's a great example of the check helping us out when we do make a little mistake, silly mistake like that. But that's substitution. We're going to get into graphing a little bit later when we get to a later section. But that's how you do that one. All right. Math puzzle break. All right, guys. I'm going to give you all, let's say, 2 minutes to solve this one. Take your time. You need to solve the final equation, and let's go. Post your answers in the chat once you got it. By the way, all of the values should be positive. It could be -6. That's a great idea, Yash. But let's go for positive values. Oh, maybe you're saying triangle 6 - 6, not -6. Yeah, got you. Okay. All right, I'm going to jump in about 20 seconds. I think we got a couple people with answers of -2/3, it looks like. Okay. All right. Let's see if anybody got the right answer. All right. Let's check it out. Now, people are saying that the triangle is 6. That is correct, which means the square must be 12, as Yash said. That is correct. And for this one, if that's 72, the pentagon is indeed 8, which is correct, which I think Yash said all of those correctly. Now, Eric is saying 6, and so is Abinet. Let's see. But we also got some -2/3. So let's figure this out. We got 8 minus 12 divided by 6. I think where we got -2/3, you did 8 minus 12, which is -4 divided by 6 is -2/3. Okay. Could be right. But what about order of operations? Are we doing subtraction first, then division, or do we have to do division first? And the answer is we must do division first, which means we have to do 12 divided by 6, which is 2. 8 minus 2, whoops, that's a funny 6, is indeed 6 for the win. That's how you do it. Oops, kind of got rid of both of those. All right, that's not working well, but 6 is the answer. Badmas, exactly, or we say PEMDAS. All right, so that was just a fun little puzzle. Hope you guys enjoyed it. We got one more at the end, so if you guys stick around, we'll check that one out as well. All right, moving on. Solving systems of linear equations, and another thing that you might get along the way, okay, is a question like this. Find a constant such that the system has, and then they'll put a constant in there somewhere, but I didn't put a constant in the example. So such that the system has no solution. All right. So when you see something where it says, hey, this system of linear equations has no solution, I want you to immediately think, oh, they're parallel, meaning they have the same slope and a different y-intercept. So an example would be y equals 3x plus 7, y equals 3x plus 12. Same slope. They both have a 3, different y-intercept, 7 and 12. And again, as I mentioned, these two lines should be parallel, so that's what they're going to look like. Now, wherever the constant is, the main idea is just remember you need the slopes to match up and the y-intercepts to be different. Usually in questions like this, just focus on the slope being the same, and you should be fine. Or they'll say, hey, it's going to have one solution. All this means is different slope. Why did I not mention the y-intercept? Because it's irrelevant. If the slopes are different, they are going to intersect no matter what, even if they have the same or different y-intercept. So an example here, -2x plus 5, x plus 2. Notice, right? We got the x plus 2, -2x plus 5 in blue. They intersect at one point. That's one solution. The intersection point is the solution. Boom, done. Last but not least, infinite solutions, same slope and same y-intercept. All right, now here's an example. Y equals x plus 4, 2y equals 2x plus 8. But you might be like, wait a minute, 2y equals 2x plus 8. Well, what is the slope? What is the y-intercept? Divide everything by 2. It's all the exact same. Meaning, same slope, same y-intercept means same equation. These are the same equations. And when you look at the graph, they're right on top of each other. Hence, it looks like you're just looking at one line. And that's because they're both the same. They're identical. And why infinite solutions? Because if they're right on top of each other, they intersect an infinite amount of times. So in a question, if you're like, hey, we need to find a constant such that they have infinite solutions, the constant needs to line up the two equations to be exactly identical. Okay. All right. Category 6, systems of linear equation word problems. All right. So we're going to jump into this question right here to explain this one. So really what it's all about for these questions is setting up correct from the word problem, from the prompt, setting up the right system. Solving it is a different question. Right here, they're not even asking you to solve it. They just want the right setup. So before I explain how to break this one down, take a minute, see if you guys can answer. Put your answers in the chat, and then we'll talk about it. All right, we got some answers coming in. It looks like we got A in the mix. All right, let's take a look here. Okay. So as we kind of breaks this down, right? Hero and Sophia purchased shirts and pants from a store, blah, blah, blah. All right. So the first thing is we want to identify what these variables are. So we start off here. We got X is the price in dollars of each shirt. Okay. And we also see that Y is the price in dollars of each pairs of pants. That's great. Okay, now what are the relationships, aka how do we come up with these equations? Well, we got this first relationship here saying 4 shirts and 2 pairs of pants cost a total of $86. Well, 4 shirts, how do I get the price of 4 shirts? I do 4 times the price of each shirt, which is X. So I should look for a 4X. 2 pairs of pants, the total cost of 2 pairs of pants is 2 times the price of each pair of pants, which is Y, 2Y. And then we should say it equaling that total of 86. I see that right here. Okay. 4X plus 2Y equals 86. I mean, I think I also, I don't see it anywhere else. So we already know the answer is A. But what now we need our second equation, our second relationship. What do we see here? 3 shirts, 5 pairs of pants for 166. So again, we should be looking for 3X plus 5Y equals 166. And that is the heart of these problems. Identifying that relationship, again, going back to the idea that we should be seeing the rate. In this case, this is price per shirt. That's a rate that should be in front of the corresponding variable. Price per pants, okay, or pair of pants. All right. Now let's talk about linear inequality word problems. All right. And by the way, A was correct for everybody, so great job. All right, again, we're going to go to this example. Valentino bought 2 containers of beads, blah, blah, blah. Go ahead, read it, give it a think, put your answers in the chat. All right, looks like so far most people, everybody's agreeing with A. Okay. So it looks like we've got some folks in here. Oops. What's going on here? Okay. So we've got our answers in here. We've got A. Now let's break this down. Okay. So Valentino bought 2 containers of beads. In the first container, 30% are red. Second container, 70% are red. Together, they have at least 400 red beads. All right. So let's break this down, right? We've got, oh, hold on one second. It's not letting me click. Uh-oh, 1 second. There we go. Okay. So check this out. First, we got where X is the total number of beads in the first container. Y is the total number of beads in the second container. So we want to get those variables. Now, we need these percentages and representations. Now, notice this, right? We've got 30% in the first container, 70% of the second container, and then that is at least 400 red beads. So let's break this down a little bit here. So to get the total number of beads in the first container that are red, we need 30% of the total number in that first container, which is X. And 30%, when we put in an equation, needs to be represented as 0.3. That's the decimal equivalent. In any equation or formula, it should be the decimal equivalent, not just 30. Same with the 70%. It should be 0.7. 0.7 of what? 0.7 of Y. And now we come to this part. At least 400 red beads. At least is greater than or equal to. And that's why we have greater than or equal to 400. Now, where it might get confusing is you might be like, well, wait a minute. At least 400, shouldn't it be 400 then is greater than or equal to blah, blah, blah? No, it's saying the amount of red beads, which is 0.3x plus 0.7y, is at least, meaning is greater than or equal to 400. So that's why it's aimed that way or set up that way. Now, just a quick little shortcut to help you with these linear inequality word problems. Remember that more than or greater than, that's your greater than symbol. Greater than or equal to, or at least, which is what we had here, at least, or no less than. Now we're talking greater than or equal to because it can equal that 400 amount, right? We're not just trying to find 401 or 402. It could be 400 and that still satisfies the language. Less than or smaller than, that's just less than symbol. And then we have less than or equal to, no more than or at most. Those are all that less than or equal to symbol. Just a quick little refresh. Eric, this is probably going to go, I don't know, another 20 minutes. But if you have to go, the replay will be up. So you'll be able to watch it. But thank you for joining. I really appreciate it. I really appreciate you joining and your participation. Okay. Now we're on to the final topic, graphs of linear systems and inequalities. And we're going to start by showing you a graph of a system, of a linear system, not a linear inequality system, because this is going to be a really useful option for solving linear systems in Desmos, because you can have access to Desmos the whole time. So for example, we have two equations. This one in green, y equals 2x plus 1. Notice the y-intercept at 1 and the slope of 2. And we have a second equation, y equals negative 2/3 x minus 7. Now, if you're asked to solve this equation, meaning find the x value of the solution or the y value of the solution, you're really finding those values of the intersecting coordinate. So for example, the solution is right there, -3, -5, because that's where these two lines intersect. So if they say the x value of the solution or something, it'd be -3. The y value of the solution is -5. And it's as simple as that. And the beauty of using Desmos in particular is whatever format this is in, point slope, slope-intercept form, even standard form, it's no problem to enter it. Like on the calculator, sometimes you have to isolate y. You don't even have to on Desmos. And that's why Desmos is so amazing. So you just write it in, look for that intersection point, and you're done. Okay, now let's talk about graphing and inequality. And again, if you have Desmos, you can just write it in and it's going to graph it for you just like this. But just so you know the protocol, or if you're looking at graphs and trying to figure out what's going on, the way you graph an inequality is first just assume it's a regular line like y equals -2x. And that would give you the line right here with a slope of -2 and a y-intercept of 0. I made it dotted because it says greater than, no greater than or equal to, no line underneath. Same with less than, it would be a dotted line. This is an indication that the line in and of itself does not contain any solutions. The line is just a boundary. And now it says greater than -2x. What does that mean? That means everything vertically above this line. So that entire shaded blue region is the representation of the solution set of this inequality, meaning any value in the blue like 9, 1, right? That's a solution. And if you put, oh, wait, that's, hold on one second. 9, 1. Yeah. So 9, 1 would be a solution because if you plug in 9 for x and 1 for y, it'd be -18 is less than 1. That's true, right? So anything that gives you a true value. 5, 5. 5 times -2 is -10, which is indeed less than 5, and so on and so forth. So that's the idea. Okay. Now, another example, y is less than or equal to x plus 1. So again, graph the line x plus 1, y-intercept of 1, slope of 1 as well. And now it's solid because it's less than or equal to. Now the values on the line are actually solutions. Very interesting. And we say less than, that means vertically below is the solution set. So all of that shaded in. And now viable points would be 2, 1. Makes sense, right? Because if you plug in 2, 2 plus 1 is indeed greater than, which is 3, is indeed greater than or equal to 1. Another viable option, 5, -5, right? 5 plus 1 is 6, is indeed greater than or equal to -5. And, oh, I didn't put an example on the line. I think I do one later on in my system. Okay. Now let's talking about graphing a system of inequalities. System means two, just like linear equations. Again, we have y is greater than -2x, which we saw before, dotted line because it's greater. Y is less than or equal to x plus 1, solid line as we saw before. But now, again, we shade below, and the solution here is the intersection point. It's this region right here that's kind of like slightly darker red, the overlap of the red and the blue. That's our solution set. So now if we're looking for points inside 7, -2, right? And again, this satisfies both inequalities. Plug in 7, plug in -2. -2 is greater than -14. Plug it in here. 7 plus 1 is 8. -2 is less than or equal to 8. So you can see that it is legitimate. We also have 8, 3, which would pass both of those as well. And 5, 6. Now, this one is actually on the line, on the purple line. And that's okay because the purple line is considered to be part of our solution set. Now we can double check this. Plug in 5, -10, plug in 6 here. 6 is greater than -10. Plug in 5 plus 1 is 6. 6 over here. 6 is less than or equal to 6. So those two are indeed equal. It still works. It's got to satisfy both. Yamilenu asks, when do you have classes? Every Tuesday at 4 p.m. PST. The verbal classes are every Thursday at 4 p.m. PST. All right. So now we're coming back to the same system. And another thing that they'll also often ask is, are the following solutions? And they'll give like 4 options like this. They'll give a little table. So again, what we can do is we can graph these values to figure out, hey, which one falls into the right solution set. But as I just showed you, as I was plugging them in, I think that's usually the easiest way and the fastest way. That's what I usually do on the test. So for example, first they have 1, 1. Let's plug it in here. Does it work here? Yep. 1 is greater than -2. How about here? 1 is less than or equal to 2. Boom. What about 2, -3? -3 is greater than 2 times -2, which is -4. That's correct. -3 is less than or equal to 2 plus 1, which is 3. So -3 is less than or equal to -3. Those two work. What about 5 and 7? 7 is greater than -10. That works. 7 is less than or equal to 5 plus 1, which is 6. 7 is not less than 6. It fails on this front. And so the following are not solutions. I mean, the first two are, but 5 and 7 is not. Now, if we looked at the graph, you can see that there's 1, 1 in the solution set. There's 2, -3 in the solution set, but there is 5, 7, and it's outside. Now it's in the blue shaded region, but it needs to be in that overlap shaded region, and it is not. Okay, guys, that is that. Here we go. We are done with the entire lecture. That is it. That is everything you need to know on the algebra section. Hope you enjoyed that whole series on the critical concept section. If you did enjoy, make sure to click that like button. I really appreciate it. And I want to talk to you guys in one quick second about the homework from last week and get you guys feedback. But before we do that, we're going to end with one quick challenge problem. Take it away. Let's see what you guys got. Put your answers below. Yes, Yash is asking there will be quizzes and assignments this week. Absolutely. We will be posting those later in the week, probably by tomorrow. We got our first answer in. All right, keep them coming, guys. Keep them coming. Got another answer that disagrees with the first answer. Very interesting. We got another 47. I'm going to give you guys another 20 seconds here. Okay, let's talk about it a little bit. Now, there's a couple ways you could solve a problem like this. I'm going to start with the traditional way. So when we have consecutive numbers, it means they're all one after another, right? So one apart. And the first one would be X. The second one would be one greater. The third one would be two greater than the original, but one greater than that. And the fourth one would be three greater than the original, but again, one greater than that. And it's saying the sum of these is equal to 182. Okay. So then we add the x's up like terms. That's 4x. We add these other ones up. 1 plus 2 is 3 plus 3 is 6. And now we can solve for x, right? Minus 6, we got 4x. Let's do it up here. 4x equals 176. Oops. Divided by 4, divided by 4. And we get x equals, I think, what is that? 44, right? So that's my little value, 44. But we wanted the largest value. So the second value would be 45. The next one would be 46. And the largest, as AO said, is 47. And that is correct. That is, yeah, Yamilenu, I think I answered your question. You said, when do you have classes? I said, we have classes every Tuesday at 4 p.m. PST for the math classes. So hope you heard it this time. And for the other way that you could have done this, a little shortcut, is you have 4 consecutive numbers, right? So what you can do as a little shortcut, just going forward, you take 182 and you divide it by 4. Okay. And when you divide it by 4, you end up getting, what is that? 91. You end up getting 45 point. You get 45.5. And you're like, well, what do I do with 45.5? Well, that's the middle number. That means the numbers go to the left and to the right. So that means to the left, we have 45 and 44. To the right, we have 46 and 47. I don't know if you like that method, but it's a lot faster. So anyways, then you get to 47, and that's how you do it. All right, ladies and gentlemen, that is it for today. Just want to get you guys answers real quick. First of all, let me know in the chat, were you guys able to complete practice test 1? And were you guys able to watch the video explanations for practice test 1 as well? I'd love to hear your thoughts. I'd also love to know your thoughts on the quizzes, if you guys were able to get those done, and if that did indeed help you memorize the information that was presented in the lecture. So we're going to do something similar for from our lecture today as well. So let me know in your chat, in the chat here, what you guys thought of all the homework assignments. All right. Yes, the quizzes are helpful. We have from Ron Beer. Okay, amazing. Glad to hear it. That's what I want to hear. I'd also love to know if, so let's just highlight that post. Yes, the quizzes are helpful. Awesome, awesome. I'd love to know from other people if you were able to get through the homework and how that's been going. And also, the quizzes are very helpful. That's what Abinet says. Okay, awesome. Very cool, very cool. And if we have any other feedback or thoughts, I'd love to hear it. If not, we can close out for today. All right. Okay, I think we're gonna wrap it up. All right, so we are done for today. First of all, a very heartfelt apology for this stream getting all messed up. As I mentioned, we had some technical issues. Hopefully, next time we won't have them, because now I'm on top of it. I know what happened, but something got messed up with the streaming software. So anyways, it is what it is, but we are back in business, and that's that. All right. So ladies and gentlemen, it says that there's something about congruent angles. We will be going over it in the geometry video. Yes, we will be, Yash. in 3 weeks. Okay. So that's it, guys. Thank you guys so much for joining. This is so much fun. I hope you guys enjoyed it. If you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. And that's that. Thank you guys so much for joining, and we will see you in the next video. Take it easy.